Okay, the last section in this chapter, we're going to talk about negative exponents and scientific notation. They seem a little disjoint at first, but they do go together nicely. So you do need to remember a couple of things. First, integers. We're going to talk about integers and natural numbers. Integers are the set of numbers that contain no decimals, no fractions, but they're like all the whole numbers and their negative counterparts. At some point, you're also going to see in a definition the natural numbers. So the natural numbers, we sometimes call them the counting numbers. And so those are the numbers that start at 1 and then increment by 1. Okay, so you'll see both of those come up in just a second. Okay, so topic 1, negative integers as exponents. Okay, so that just means now our exponents, they can be negative. Before they couldn't. Now we're going to say, okay, we have these negative exponents. How do we deal with it? How do we make them positive? That's what this is going to show us. So for this video, we do need to remind ourselves of one of our properties for exponents. Okay, so it says when dividing exponential expressions with the same non-zero base, we keep the base and subtract the exponents. That's the quotient rule for exponents. So if we had b to the m divided by b to the n, we keep the base of b and then we subtract the exponent, so we get b to the m minus n, just as long as b is not 0. If b is 0, we get weird undefined stuff. Okay? So keep that in mind. We're going to look at a couple of things here. We're going to see if we can prove this idea of negative exponents. So let's say that we have the following expression, a to the third divided by a to the fifth. Okay? Well, if we look at this just in terms of like canceling stuff top to bottom in fractions, we've done lots of that in the past. If we think of it in terms of that, we can look at a to the third as a times a times a, divided by a to the fifth, which is a times a times a times a times a. Well, what happens is a lot of those a's cancel out. So A and A cancel, but remember, things don't just disappear in math. When we say things cancel, it either cancels to become a 0, or in this case, it cancels to become a 1. So A divided by A is really just 1. A divided by A is really just 1. A divided by A, still just 1. And then in the denominator, I'm still left with a couple of A's. So this would simplify. The numerator would just be 1 times 1 times 1, which is 1. The denominator would be a to the second power. And hopefully that kind of makes sense if you think about it logically. Without multiplying this out, without showing this work, hopefully you could still come to this conclusion, because if you think of this, a to the third divided by a to the fifth, this is kind of bottom heavy. We have more a's in the denominator than the numerator. We can still just subtract our exponents. 5 minus 3 is 2, but where do those extra 2 a's live? Well, because we're bottom heavy on a's, those extra a's live in a denominator. So we're saying now that a to the third divided by a to the fifth is equal to 1 over a squared. Now let's look at this exact same problem, but using the quotient rule, okay? So using the quotient rule, we know that if we're dividing two terms that have the same base, we keep the base and then we subtract the exponents. So if we do this literally, we have a to the third divided by a to the fifth. So we have the same base a, we keep the a. We subtract the exponents, and using the quotient rule, you always take the top exponent minus the bottom exponent. So 3 minus 5 is negative 2. So what we've just done is we've taken this expression, a to the third divided by a to the fifth. We've looked at it two different ways and we've gotten two different results. So it kind of goes without saying that those two different results must also equal each other. So we could say that a to the negative 2 power is the exact same thing as 1 over a. And that is the rule for negative exponents. So let's look at the negative exponent rule down here. So the negative exponent rule says if b is any number other than 0 and n is a natural number, then b to the negative n is equal to 1 over b to the n. Similarly, what if that b to the negative n is in a denominator? Well, that's fine. 1 over b to the negative n just becomes b to the positive n. So essentially, think of things that contain negative exponents as fractions. Whatever factor has the negative exponent just needs to trade places in the fraction, okay? So as long as you can see these terms as fractions, so you could see this as b to the negative n over 1, well, the b to the n comes to the denominator, leaving a 1 behind in the numerator. And then for the second one, this b to the n in the denominator moves to the numerator. Okay, we don't flip the fraction. That's not what happens. We're just moving the factor that has the negative exponent to the opposite side of the fraction. Okay, so let's look at some examples. Example 1 says simplify each exponential expression. Well, let's look at this. So think of this 2 to the negative 3 power. I'm going to think of it as negative 2 to the third over 1. I just want to have a distinct numerator and denominator. That's why I'm putting it over 1. Well, 2 to the negative third is really the same as 1 times 2 to the negative third. The only thing that moves is the thing that has the negative exponent. This needs to move in order to make that exponent positive. So when it moves, it leaves that 1 in the numerator, and then in the denominator, it just becomes 1 times 2 to the positive third, which is 1 over 2 to the third. Now, anytime your base is a number, you do want to go ahead and evaluate this all the way out. So since my base is 2, I want to go ahead and figure out what 2 to the third is. Well, 2 times 2 is 4. 4 times 2 is 8. So this would simplify to be 1/8. Okay. Now for part B, it's a little bit different. We have 5 times x to the second power. So let's think of this as 5 times x to the negative second power over 1. I just like to see a distinct numerator and a distinct denominator. Well, this now becomes 5 times x to the negative second power over 1. I write it like this so you understand that the 5 and the x to the negative 2 power, they are separate factors. That exponent of negative 2 only applies to the x. It does not apply to the 5, okay? So the only thing that's moving is x squared. So in the numerator, that leaves my factor of 5. My denominator now becomes 1 times x squared. Once the factor moves places in the denominator, the exponent becomes positive. So this just becomes 5 over x squared. And that's it. Okay. Now for part C, this already looks like a fraction. So I do want to point out that this is 1 over 1 times x to the negative 7 power. Okay. Now the only thing that's moving is x to the negative 7 power. It needs to move to the numerator. So the numerator becomes 1 times x to the positive 7 power. The denominator, we left a 1 behind. So this becomes 1 times x to the 7th over 1, which is really just x to the 7th. So this one you could have just jumped right to the chase, but I want you to see why that is, okay? Like how we go from 1 over x to the 7th to just plain old x to the 7th. Sorry, my voice is scratchy from making bunches of videos today. Now, looking at part D, we have 4 distinct factors between the numerator and the denominator. In the numerator, we have 2 factors, 3 and x. In the denominator, we have 2 factors, 2 and y to the negative 4th power. Only one of those 4 factors is moving, and it is the y to the negative 4th power. That's the only thing moving, okay? So we want to move that to the numerator. So we still have 3 times x in the numerator, but now we have y to the 4th. The exponent becomes positive when it changes places in the fraction. We left a 2 behind. So this becomes 3xy to the 4th all over 2. And that's it. So you definitely see negative exponents from time to time. You're going to see them, honestly, more with scientific notation than anything. But there you have it. That's the basic steps to dealing with exponents that are negative. They just change place in fractions.